Hello everyone, hope you all are well. Today we are going to discuss memory organization. The topic that's going to be covered is mode of data transfer. Mode of data transfer. The binary information that is received from an external device is usually stored in the memory unit. The information that is transferred from the CPU to the external device originates from the memory unit. The CPU merely processes the information, but the source and target is always the memory unit. Data transfer between CPU and the I/O devices may be done in different modes. Data transfer to and from the peripherals may be done in any of the three possible ways: programmed I/O, interrupt-initiated I/O, direct memory access (DMA). Programmed I/O. It is due to the result of the I/O instructions that are written in the computer program. Each data item transfer is initiated by an instruction in the program. Usually, the transfer is from a CPU register and memory. In this case, it requires constant monitoring by the CPU of the peripheral devices. Example of programmed I/O. In this case, the I/O device does not have direct access to the memory unit. A transfer from I/O device to the memory requires the execution of several instructions by the CPU, including an input transfer instruction to transfer the data from the device to the CPU and store instruction to transfer the data from CPU to memory. In programmed I/O, the CPU stays in the program loop until the I/O unit indicates that it is ready for data transfer. Interrupt-initiated I/O. Interrupt-initiated I/O. Since in the above case we saw the CPU is kept busy unnecessarily, this situation can be very well avoided by using an interrupt-driven method for safe data transfer. By using interrupt facility and special commands to inform the interface to issue an interrupt request signal whenever the data is available from any device. Note: both the methods, programmed I/O and interrupt-driven I/O, require the active intervention of the processor to transfer data between memory and the I/O module. And any data transfer must traverse a path through the processor. Thus, both these forms of I/O suffer from two inherent drawbacks. Number one, the I/O transfer rate is limited by the speed with which the processor can test and service a device. Number two, the processor is tied up in managing an I/O transfer. A number of instructions must be executed for each I/O transfer. Direct memory access. The data transfer between a fast storage media such as magnetic disk and memory unit is limited by the speed of the CPU. The DMA, therefore, we can allow the peripherals to directly communicate with each other using the memory buses, removing the intervention of the CPU entirely. This type of data transfer, known as DMA or direct memory access. The bus request. It is used by the DMA technique controller to request the CPU to relinquish control of the buses. Bus grant. It is activated by the CPU to inform the external DMA controller that the buses are in high impedance state and the requesting DMA can take control of the buses. Once the DMA has taken control of the buses, it transfers the data. This transfer can take place in many ways. Types of DMA transfer using DMA controller. Bus transfer. DMA returns the bus after complete data transfer. A register is used as a byte count, being decremented for each byte transfer, and upon the byte count reaching 0, the DMAC will release the bus. When the DMAC operates in burst mode, the CPU is halted for the duration of the transferred data. Steps involved are: bus grant request time. Transfer the entire block of data at transfer rate of the device because the device is usually slower than the speed at which the data can be transferred to the CPU. Release control of the bus back to CPU, so total time taken to transfer the n bytes equals bus grant request time plus n times the memory transfer rate plus bus release control time. Cyclic stealing. An alternative method in which the DMA controller transfers one word at a time, after which it must return the control of the buses to the CPU. The CPU delays its operation only for one memory cycle to allow the direct memory I/O transfer to steal one memory cycle. Steps involved are: buffer the byte into the buffer, inform the CPU that the device has one byte to transfer, that is bus grant request, transfer the byte at system bus speed.